And thank you for coming to this event, Careering Towards Climate Change, presented by Simon Buckle. This talk is being held as part of the Kennedy College of Sciences Bring It to Science Week, and it is part of our Chaisson Lecture series. We hope that some of you can join us for our other events happening this week, and for details on those, I will put the link to our Spring Into Science website in the chat so you can check those out. We are very grateful to Eric Chaisson, class of 1968, and Lola Chaisson for their support of the Kennedy College of Sciences lecture series on science and society. And we hope to host our next lecture on campus this fall. So stay tuned for details. We also wanted to let you know that we have Days of Giving coming up tomorrow, the 13th of April and 14th of April, which is Thursday. And we'll put the link in the chat as well for any donations you may want to give. You may have seen from Graham, our event support specialist, that for the webinar, we will have both the chat feature as well as the Q&A feature available. So you could access those on the bottom of your screen. And we ask that you put all questions in the Q&A and any just like general chat in the chat section. And with that, I will turn the floor over to Dean Malikshi of the Kennedy College of Sciences, and he will take it from here. Noordine.
Thank you, Liz. Thank you. Thank you so much. And thank you to everyone who is here with us today, and welcome. So as Liz said, this is part of our Spring Into Science. We have Spring Into Science in April, where we have a lot of events, and I invite you to go and check the events that we have. And I would like to take also this opportunity to thank Eric and Lola Chaisson for their support. And as Liz said, this is part of our series. We'll hear this today of Eric and Lola Chaisson's lectures. With that, I'm really pleased and very happy to have with us this afternoon a great friend. We share a lot of memories together. We were in graduate school together, and somebody I have a lot of respect for, Dr. Simon Buckle. And I'll introduce Simon now. So Simon has done a lot of things. I'm not sure I can go through all what I have here, but I will tell you what Simon has done so far, and in this introduction. So Simon was the head of division responsible for climate biodiversity, water and sustainable finance within the Environment Directorate at the OECD, which is the Organization for Economic Cooperation and Development. His division's work has had an important impact on national and international policy developments, including a groundbreaking report on climate finance that helped prepare the ground for the Paris Agreement in December 2015. Influential reports, also he developed influential reports on biodiversity for the G7 meeting in 2019 and 2021. And worked on climate finance and losses and damages from climate change that fed into discussions at the COP26 meeting, which was held in Glasgow. During the 2018 and 19, Simon was the OECD's representative at the EU, so the European Union's technical expert group on sustainable finance, and contributed in particular to its taxonomy work. He was recently also the chair of the External Advisory Board of the Imperial College Graduate School for 3 years. And before joining the OECD in 2014, Simon was the founding climate policy director at the Grantham Institute at Imperial College in London. And for part of that time, he was also a member of the Imperial College Management Board. Simon played a leading role in the creation of the European Institute for Innovation and Technology, Climate Knowledge and Innovation Community. And previously, he was a senior British diplomat. Yes, he was. And served in a variety of senior roles, both in London and overseas. Simon joined the UK Foreign and Commonwealth Office in 1986, and has also worked at the Bank of England from 1998 to 2002. He also worked at the UK Ministry of Defence from 1988 to 1991, and as a postdoctoral researcher in quantum optics at Imperial College. Simon has a doctorate in theoretical physics from University of Sussex in England, a master's and MS in financial economics from the University of London, and a bachelor's joint with honors first class in physics and philosophy from University of Bristol in England also. Simon was made a companion of the Order of St. Michael and St. George in 2007 and is a fellow of the Institute of Physics. What an achievement. Great to see you, Simon. And again, I just want to thank you, Simon, for I know how busy you are, for taking the time from your busy schedule to do this for us. Thank you so much. So the floor is yours. And Simon is going to talk to us about climate change clearly, and I'll let him define that. Thank you, Simon.
So thank you very much indeed for those warm words of welcome, Nordine and Liz. And I must say it's a great honor and pleasure to have been asked to deliver this year's Chaisson Lecture at the University of Massachusetts Lowell. And grateful to you, Nordine, for the invitation, which of course, this event should have happened a couple of years ago, but COVID got in the way and we're still doing it virtually, but we couldn't delay it any longer. So really pleased that we've managed to make this happen. So you've talked a lot about my background, so I can skip a fair bit of my first page of remarks, which is good. That'll save us some time for questions and discussion later. Just really to say that at Sussex, when Nordine and I were studying and researching together, you know, he was an experimentalist, I was a theoretical physicist, and what interested me at the time was really the study of complex many-body systems, collective effects, and the potential for phase transitions to shift a system from one state to a completely different one. So, for example, the transition of a normal fluid to a superfluid at low temperatures, or the onset of ferromagnetism when you pass some sort of critical threshold temperature. And this fascination with collective behavior and transitions is perhaps the leitmotif of my own career, which has seen many transitions of its own, as Nordine has mentioned. And the title I chose for the lecture really reflects this and plays on the double meaning of the word career in English. One meaning might be an occupation undertaken for a significant period of a person's life, okay? A second meaning, of course, is to move swiftly and in an uncontrolled way. And both meanings might apply to my own career, I think. I'll leave you to judge. And I'll talk a little bit about the institutional and historical context of the work that I've done on climate in 3 different organizational settings in the first part of the lecture. And in the second part of the lecture, I'll then actually focus on the substantive issues around climate change. The way we are careering towards the sort of dangerous climate change that the 1992 UN Framework Convention on Climate Change was created to avoid. And I'm going to discuss some of the potential implications, the response options we have, and the challenges we face in trying to reduce and manage those climate risks, which are going to grow in the coming decades. So let me move swiftly to talk about the 20 years ago where I was in the Foreign Office, and I wasn't working on climate change. I was in the strategy director's area of work, and they were producing a strategy white paper for the UK government, foreign policy paper. And I was arguing really for a greater focus on climate change in foreign policy. And this, I wasn't the only one doing this, there were others, but you know, I was in the right place at the right time, I guess. And my physicist's instincts told me that this was a massive challenge that was really very underappreciated by the vast majority of policymakers at the time. And I can probably take a little bit of credit, not too much, but a little bit, for persuading those people who were writing that strategy white paper to include climate change alongside and on the same level as the more traditional foreign policy concerns. Climate change was also an important part of my final diplomatic role. I was the Counselor for Global Issues and Strategic Threats at the British Embassy in Paris in 2006 and 7. A major focus there was really engaging the French government, French academia, civil society on the analysis and key recommendations of the Stern Review, which you might call from 2006. called The Economics of Climate Change. And this had been commissioned by the then UK Chancellor of the Exchequer, Gordon Brown, who went on to become the Prime Minister. And it formed an important element of the UK's efforts to accelerate global action on climate. Many of the people I got to know in Paris at that time were also important later in my career, notably Professor Laurence Toubiana, who ran a Paris-based think tank and was a key player in securing the Paris Agreement in 2015, COP21. And I also got to meet someone with whom I worked closely in the subsequent years I spent at Imperial College, and that's Professor Georgina Mace, who's a noted ecologist. And we invited her to Paris to give an important talk that reminded us that we face not only a climate crisis, but a deeply interconnected, but hugely under-recognized biodiversity crisis. Tragically and far too soon, Georgina died in 2020, which is very sad. When I was approached to become the policy director at the Grantham Institute at Imperial College in 2007, I didn't really hesitate. And this explains my short duration in Paris, as it were, two years maximum. It seemed like the perfect opportunity, though, to leverage the cutting-edge research at Imperial to inform the rapidly evolving policy landscape on climate change, both in the UK and internationally. And it was clear to me that climate change was where my interests for the future lay. So I jumped. At that point, of course, the Institute only existed really on paper. We soon began, though, to articulate a vision for a multidisciplinary research institute that would have real-world impact in terms of the science, the strategies, policies, technologies needed to address climate change. And as the name suggests, it was very generously funded by the Grantham Foundation. And both Hannah and Jeremy took a very close personal interest, and you'll be aware that they're based around your neck of the woods. The Grantham funding enabled us to make new academic appointments in key areas of climate research where Imperial perhaps didn't have the expertise at that time. And in partnership with the academic departments, we also established a novel multidisciplinary PhD program, and separately then, to give the Institute some core capability, created a modest policy and operations team. It was only about 3 or 4 months later, after I joined, that the head of Imperial College persuaded Brian Hoskins to become the inaugural director of the Institute. And you may know, but if you don't, it's worth knowing. Brian's one of the leading dynamical meteorologists of the last 50 years, an applied mathematician, and the recipient of many prestigious honours and awards for his work, including the National Academy of Sciences Foreign Associate. So over the years, many universities had tried to pry Brian away from the University of Reading. No one had succeeded until then, and even then we only got him part of the week. So we were lucky to get 3 days of his time. Brian and I hit it off very quickly, and we worked closely and happily together for the next 7 years, and establishing the Institute as a vibrant hub of activity across the university and building impact and reputation externally. And to complement the overwhelming STEM focus of Imperial, Jeremy and Hannah had the vision and commitment also to establish a second Grantham Institute at the London School of Economics. And later on, they also established a Grantham Chair in Climate Science at the University of Reading. So they've really had a transformational impact on climate research and knowledge exchange in the UK from their investments and support. A key question for the Institute in those early days was how to position it within a university absolutely packed with ambitious world-class academics. And you all know the sorts of people that we are talking about, I imagine, from your own institutions. The prevailing incentives for the academics and departments made that task more challenging than it should have been. What mattered for the university and for an individual's career were high-quality publications, citations, success in attracting external funding, and of course, teaching and doing PhD supervisions. And that's all pretty demanding and time-consuming on its own. Contributing to better government policy or improving public understanding of climate change were not seen as so important when it came to contract extensions and promotions, and such activity took up precious time from the things that were. But the Grantham's core funding gave us the means to begin to change the incentives. We could attract outstanding students. I mean, Imperial did anyway, but these were, really, really outstanding students who were excited by the mission of the Institute and were themselves committed to making a difference. And we helped to break down silos across the university and even within faculties themselves, and to influence their priorities for future academic appointments. And on top of this, the Institute could offer access to new funding and opportunities to engage with policy and business that individual academics and even individual faculties could not easily obtain. I look at the UK funding landscape now, and I'm happy to see that multidisciplinary doctoral schools and greater funding for knowledge exchange are really taking off. And both of these were things we pioneered early at the Grantham Institute. And when I started to think about what I might say today, I took a look at the University of Massachusetts Lowell website, and I was really pleased to see that you've got a significant cross-university activity on climate change, energy, and urban sustainability. The work of the RIST Institute, for example, encompassing research, education, and community engagement, really resonated with me. So that's a great pleasure to be able to talk to you about some of the parallel things that we did at Imperial. One of the high points of that time, as Nordine's briefly mentioned, was the creation of this institution called the Climate Kick, a pan-European knowledge and innovation community. And this was Europe's response to the lack of a Silicon Valley equivalent in the continent. And they put big bucks on the table to try and create these new knowledge and innovation networks to drive innovation and growth across Europe. And I spent, therefore, the whole of 2009 basically developing the bid alongside colleagues from Imperial, other leading universities on the continent like ETH Zurich, and we built a broad consortium of universities, research institutes, companies, and regional governments. And it was a special moment when the scientists leading the joint French and German initiative, and those are people I knew from earlier in my career, actually asked to join our consortium. And you can imagine what that means to a British-led consortium, having France and Germany come to us for a change. Things have changed a little bit now with Brexit, but at the time that was quite dramatic. But anyway, this was a great success. It was basically the top-rated bid across Europe, and I'm pleased to say that the Climate Kick is still thriving today under the leadership of Kirsten Dunlop, addressing such issues as healthy, clean cities, resilient regions, and climate-friendly food systems and diets. As well as the university's knowledge exchange program, I also developed and ran, the Institute's knowledge and exchange program, I also developed and ran the mitigation program, which was and continues to be quite a distinctive element of what the Institute can offer because of Imperial's strengths in the areas of engineering in particular. An early success was working with one of the PhD students we'd taken into the Institute to marshal advice from a wide range of academics on things from carbon capture and sequestration to photovoltaics to transport, to inform UK government officials in advance of their developing a 2050 strategy. And this was 10 years before the rest of the world decided that a 2050 strategy was a good idea to have. So full credit to the UK government of the time for its leadership and foresight there. Now, encouraged by an apparent hiatus in climate warming following the 1998 El Nino event, which I don't know if you remember it, but it was something that sparked wildfires across the whole of Southeast Asia, and there were massive plumes of smoke polluting Korea and mainland China for years. I know because I was in Korea at the time. And then subsequently, the failure of the Copenhagen climate meeting in 2009, climate science, individual climate scientists, and climate policy came under increasingly political attack. And it was quite vicious. Brian and I, therefore, spent quite a lot of time speaking to the media and challenging the disinformation spread by some influential politicians and lobby groups. And we were able to inform emerging policy thinking through our communications activities, our events, bespoke briefing and discussion papers, and all these different channels that we use to reach out to people. And the aim was to be authoritative but accessible, basing ourselves on the best possible evidence. And as was true then, it's true today, the IPCC's reports and messages are an important resource in that struggle to counter well-funded efforts to sow doubt about the science and to delay action. I think the arguments now moved more from challenging the science to delaying the action, but the IPCC remains an important body. So after 7 years at Imperial, Brian stood back, and I also decided it was time for a new challenge, one with greater opportunities for engaging with policymakers internationally. And I accepted an offer to become, as Nordine said, the head of the Climate, Biodiversity and Water Division at the OECD. The OECD is Paris-based, funded by its 38 member governments, and provides evidence-based policy analysis and recommendations, develops standards and supports policy networks like the G20 and the G7. So the OECD enjoys unrivaled convening power. It's got close relationships with its member governments and the wider international community. And that means that if you do good analysis and have good recommendations, your reports can have a really important impact internationally. And you know, we've done some of those, and I don't want to labor it, but the climate finance one that led to COP21 and the Paris Agreement was important in facilitating the process. Nobody knew where countries were on their commitment to mobilize and provide $100 billion by 2020 for climate action by developing countries, and we gave them an answer. Not everybody liked the methodology, but it gave over time a consistent basis for judging progress. And the OECD was also one of the first major international organizations, I think, to take sustainable finance seriously. The OECD is steeped in economic orthodoxy, though, but it's also a little bit schizophrenic because it promotes green growth on the one hand, but then it also acknowledges the need to go beyond GDP and to think about other metrics of social welfare like well-being. And in the second part of the talk, to which I'm now going to turn, it's going to be clear where my own intellectual sympathies on that issue lie. So I'm going to share a screen now because I think some of the issues around the substance of climate change are going to be more helpfully explained, perhaps with a few slides. So just bear with me a second while I do that. Now, hopefully you should be able to see this in slideshow mode. Okay. Everything all right? You can still hear me? You can still see me? Good.
Yes, we can, Simon. We can hear you and we can see the slide.
You can see the slide, fine. Okay, great. That's just my opening slide, so that's nothing to really talk much about, apart from the fact that it's showing this very steep acceleration and warming after 1980, and that's from a NOAA analysis of temperature anomalies. So what I'm going to talk about really today are these issues. So I've been through quickly the career in climate. Move on to what is climate change. That's going to be very brief. Talk a bit about the climate impacts that we're expecting and are projected, the policy responses we have, the challenges to effective climate action, and then some personal reflections. Now, it's quite a lot to in. I'm going to try, so bear with me. So even small concentrations of water, carbon dioxide, and other greenhouse gases present in the atmosphere have a massive effect on the climate. Without them, the surface temperature would be some 33 degrees cooler. And that's determined by the point at which the energy from the incoming solar radiation is balanced by the outgoing low-frequency infrared radiation reflected from the Earth's surface. And simplifying hugely, the greenhouse gases in the atmosphere change the energy flows, and the greenhouse gases in the atmosphere absorb some of this outgoing infrared radiation and then re-radiate it back to Earth, thereby increasing the surface temperature significantly. And here you can see the record of rising greenhouse gases. The CO2 one is the longest here, and we now know that CO2 concentrations are higher than at any time in at least the last 2 million years. Concentrations of methane and nitrous oxide, which are powerful greenhouse gases, have also continued to rise sharply and are higher than at any time in the last 800,000 years at least. So CO2 concentrations reached 420 parts per million at the start of April. That's more than 100 parts per million higher than when I was born. Worryingly, the growth rate has even increased since the UNFCCC agreement was adopted, and methane emissions in 2020 and 21 set new records. So we're not out of this problem by any means. Despite the political aspirations and commitments, emissions are still going up. Average temperature is now more than 1.1 degree warmer than the 19th century, late 19th century average. 1850 to 1900 is the reference period, unless stated otherwise. And you can see on the left panel here of the slide that we've got a reconstructed temperature profile from paleoclimate work, and the massive spike in temperatures as we enter into the 20th century. And the right-hand panel really shows that our understanding of the quantitative understanding and ability to simulate climate is pretty impressive. And you'll see there, two lines, one that includes the greenhouse gas forcing, and that follows the actual data pretty closely. And then if you do a simulation without the greenhouse gas forcing, but you've only got the natural sort of variability from the sun and volcanoes putting aerosols into the atmosphere, you can't replicate the temperature series that we have, that we've measured. So that's pretty compelling evidence that A, the climate is changing, and B, we can simulate it at a global level pretty compellingly. Right. Last 10 years really have been exceptionally warm, and I think all of the top 10 warmest years have taken place in this century. So even the warming in 1998, which was exceptional at the time, is now dwarfed by the temperatures we're reaching. Now, moving on to the impacts. Unchecked climate change is going to have severe, pervasive, long-term, and likely irreversible consequences. And we're already seeing the impacts of climate change on human systems. This slide is from the IPCC's Working Group 2 report, just published in February, and it summarizes with pluses and minuses the impacts in 3 important areas: water and food, health and well-being, cities and infrastructure. You can see there are a few examples, very few examples, where the impacts, are mixed across a region or an issue. You get both positive and negative changes, but overwhelmingly the changes are negative, particularly for health and well-being. So that's quite a scary picture. That's just what's happened now with the 1 degree warming we've had. Now let's think about these risks a little bit more abstractly. This is the IPCC's conceptual diagram to capture what climate risk is, and it's really a function of the hazards, frequency, intensity of climate hazards, exposure of people, sets and ecosystems to those hazards, and their vulnerability. How sensitive are they to that hazard? And hazards really are determined by the pace and extent of climate change and natural variability. Exposure and vulnerability are, however, functions more of socioeconomic processes, institutions, policies, governance. And the actual impacts that people suffer, if you like, are the crystallization of the climate risks at the point when the hazards, the exposure, and the vulnerability intersect at a particular place and time. Now, the increase with each increment of warming, and this slide here illustrates the different levels of warming. That for different levels of warming, extreme heat events are going to become both more intense and more likely. You can see events here, two types of events that would have happened on a 10-year frequency in the absence of climate change, and events that would have happened on a 50-year frequency, if you like, and dramatic increase in the frequency of these as you move through 1.5 degrees, 2 degrees, and 4 degrees of future warming. This is really scary, particularly when you recall the events of last year, when Lytton village in British Columbia recorded a maximum temperature of 49.6 degrees centigrade, staggering 4.6 degrees higher than at the previous maximum temperature ever recorded or observed in Canada. So that's a taste of what's to come, and we really want to be going up to these extreme levels of 4 degrees. You know, if we can limit warming below 2, which is the goal of the Paris Agreement, it's still bad. It's a lot better than it could be. One of the most significant effects of climate change is on the planet's water cycle and on weather patterns. And in July, parts of Europe saw 2 months of normal rainfall in just 2 days. It caused floods leading to around 200 deaths and an estimated $40 billion of damages in Germany alone. The widespread drought in Western North America became more extensive and severe in 2021, and the economic losses of Hurricane Ida in the US last year were estimated at nearly $64 billion. And that's in addition to the 72 direct and 43 indirect deaths in the US and Venezuela from that hurricane. Now, we can think about extreme events as the archetypal sort of climate effect, but there are 2 others we need to mention. One is slow onset changes, such as increasing average temperatures, ocean acidification that damages marine life, rising sea levels, retreat of glaciers on land, and shifts in the distribution of species, which are happening pretty rapidly. So while they're called slow onset changes, actually it is really fast on geological or evolutionary timescales. And we're already seeing the impacts of these. So, for example, storm surges and coastal flooding are made worse by higher sea levels. And we know that these coastal flooding events are amongst the most devastating of natural disasters. Second type that we need to think about are tipping points. IPCC defines a tipping point as a level of change in a system properties beyond which the system reorganizes, a bit like a phase transition, if you like, from physics. And this is often in a non-linear manner, and quite often the system shows hysteresis. It doesn't return to the state it was in before, even when you take away the drivers of change. And major tipping elements in the system are shown here, and they include things like the collapse of the West Antarctic ice sheet. You can see that in the sort of blue color. The collapse of the Atlantic meridional ocean circulation, that's in the orange. That's often referred to as AMOC because it's just too difficult to say otherwise. Coral reef earth, you can see that in green in the Southeast Asian region, and Amazon rainforest dieback. So those are the sort of threshold of the climate system that could really cause a complete reorganization of the climate system and would have very widespread impacts, as I'll describe in detail just now. So we did a report on managing climate risks facing up to losses and damages. You can see the title at the bottom of that slide, just before COP26. And as part of this, we got the University of Exeter to contribute an analysis of the implications of a collapse or weakening of AMOC on the climate system. And you get really noticeable cooling, several degrees cooling in the Northern Hemisphere. But you also get, effects on ecosystems, human health, livelihoods, food security, water supply, and economic functioning at a global scale. And the changes in sea surface temperature and rainfall patterns in the tropical Atlantic would likely lead to the loss of the Amazon rainforest and exacerbate already projected reductions in West African rainfall. And these are shown as well as 2 of these tipping elements. And so while the IPCC assesses that the shutdown of the AMOC is very unlikely this century, probably less than 10% likelihood, it also says that such a collapse can't be ruled out. And the AMOC is already at its weakest in a millennium, and this slowdown is likely to continue as Greenland ice continues to melt. And there's similar concerns about other ice sheets. You might have seen news about the East Antarctic ice sheets in recent weeks. So let's move on to policy responses. Enough of doom and gloom impacts. Now, if we return to this diagram of the conceptual diagram of risk. You know, there's three ways in which we can actually reduce and manage climate risks. One is limiting the hazards, one is reducing vulnerability, and the third is reducing exposure. Now, these are all going to be determined by really complicated and rapidly evolving political, economic, technological, and social trends and choices. And together, these are going to determine pathways for countries and globally over time. What the Paris Agreement calls for is a shift to low emissions, climate resilient development pathways. And it was recognized at that time that achieving emissions reductions would take longer in developing countries than in developed countries. Now, how do we reduce the hazards? Well, the key way is mitigation, or reducing the emissions that we're putting into the atmosphere and increasing the ability of natural ecosystems to store greenhouse gases like carbon dioxide. You know, ecosystems like forests naturally draw down CO2 to help them to grow, and they store it for long times, not for thousands of years, but maybe 100 years or so. And if you can keep those forests intact and replenishing after generation, you're actually storing the carbon there instead of in the atmosphere. So effective mitigation requires policy, institutional and human capacity, finance, technology. Most of the attention and the news, focuses on supply side technologies, the wonders of, PV or direct air capture of carbon dioxide and so on. The vitally important demand side measures needed to reach the very low emissions that we need to get to in the next decades frequently get ignored. They're too difficult. They're not sort of as newsworthy, maybe. Now, there has been progress in terms of a number of dimensions, really. I mean, the technologies are the obvious ones, and this is why people focus on them in their news stories, I guess. But you can see the dramatic fall in the costs of photovoltaics, wind technologies onshore or offshore, and concentrating solar power, and also batteries for electric vehicles. And now some of these technologies, even without a carbon price, even without counting the costs from health and other economic costs from air pollution, that the World Health Organization estimates at something like 2.9 trillion in 2018. And those are directly linked to fossil fuel combustion. Even without counting those costs, just on a levelized cost of electricity, these technologies are now competitive or even cheaper in some locations than fossil fuel generation. And that's remarkable. That is remarkable. And that gives us hope that we can move quickly to decarbonize electricity supply. We're trying to keep emissions to a level that allows us to reach 2 degrees, well below, maybe 1.5 degrees if we can. And some countries, you look at the US over recent years and the EU over a longer time period, have managed to reduce emissions on a sustained basis. But only a handful of countries are actually doing so at a rate that is consistent with these targets of 2 degrees or 1.5 degrees. And you look at China and India, and they've said, well, we're not going to peak our emissions till 2030 or 2040, 2045, respectively, because we're developing economies and we still need the fossil energy to grow. And they've got good arguments for that. However, it is not helping us to keep climate risks within manageable bounds. And against the 1.5 target, Climate Action Tracker, which assesses policies and actions on climate change mitigation, sees both China and India as highly insufficient. Their efforts as highly insufficient. The US gets away with just an insufficient rating. We now look at the chart that IPCC put out in their latest Working Group 3 report just a few days ago. You can see this happening at a global level. This is global emissions, and for all gases. So you can see the proportions, you know, fossil CO2 from in the blue is nearly 2/3 of global emissions. Carbon dioxide emissions from land use change, forestry, that's, you know, 11% of emissions, and methane, you know, just under 20% of emissions, the others smaller shares. That gives you the big challenges, you know. If you link that back to the sectors, energy supply, industry, forestry, agriculture, land use, major challenges here, and transport and buildings too. Even though they appear smaller, when you take the emissions that are embodied in the electricity used in buildings or industry, for example, for those percentages would be higher. And you can see the percentage growth in these different gases since 1990. That's a huge increase in CO2, slightly lower in nitrous oxide and methane. Now, fossil energy remains 80% of our energy supplies globally, and support to fossil fuel production consumption, subsidies in other words, is worth around $350 billion as of 2020. And this really impedes mitigation efforts and is hard to reform. Deep reductions in these non-carbon dioxide greenhouse gases are also needed. You know, methane and nitrous oxide cuts will have major implications for the way we do agriculture, for diets and everything if we're serious about this. And yet we know that sharp cuts in methane have the potential to both reduce the rate of warming and the peak temperature that we get to this century, while delivering significant health benefits. Yet somehow we're just struggling to get control of this problem. And current policy set suggest that emissions will plateau at around 60 gigatons of CO2 equivalent in emissions per year in 2050. That's shown by the red shading in panel A of this slide. And the 153 nationally determined contributions, you know, what countries say they're going to do in advance of COP26 in Glasgow last November, are very diverse, reflecting country conditions, but actually they don't make much difference to that. So if you look at panel B, you know, you're reducing the projected level of emissions in 2030 just by a few gigatons, whereas actually we need to be 30 or 40% below that to be on track for one of these pathways, the blue, the green, or the purple pathways that actually are consistent with a 2 degree or 1.5 degree target. And the NDCs, these commitments by countries, you know, are also completely out of kilter with the commitments, political commitments made by countries to achieve net zero sometime, you know, around the second half of the century. And those commitments now cover 90% of global emissions. But the action is nowhere near that level of ambition. I'm just looking at the time quickly because we're running out. So let me move on. Adaptation is the action that we need to address vulnerability and exposure. And we can see here that it's therefore a complementary action to mitigation. It's hitting those two light blue shapes rather than the dark blue hazard shape. And adaptation primarily aims to secure, you know, local or regional benefits, so the politics of it are less difficult than mitigation. You know, people, countries, firms have a real incentive to increase their own resilience. Now, vulnerability is going to vary a lot across economic regions, geographic regions, economic sectors, and social class. It's going to vary as well in terms of the effects on characteristics such as gender, ethnicity, age, health, you know, what occupations different genders have, the ability of old people or infirm people to move out of the way of extreme events, and so on. And adaptation, therefore, is going to need to be location, context, and hazard specific. A low-lying coastal zone faces very different challenges, as we know, to a mountain community, for example. And some of the hazards are going to change over time. So malaria is going to spread. That's going to expose new populations to that disease. And adaptation can also have unintended consequences. So if you build a levee and then everybody builds their houses and moves to live behind it, thinking they're protected from floods, when you get the big flood, they're not so happy. Decision makers have got to determine which hazards to address and how and to what extent and when. And responses to some hazards may be gradual, and building options for future strengthening of those measures, like the Thames flood barrier. Alternatively, a very intense hazard, like a major wildfire or a major coastal flood, might actually lead people to migrate internally or internationally. And there are likely to be limits to how much people can reduce their vulnerability and exposure if hazards just keep growing. So there's going to be, if you like, soft limits and hard limits. Soft limits might be financial, political, economic, social, cultural constraints that kick in well before the technical constraints of protecting a low-lying coastal area, for example, or the physiological limits of working in extreme heat and humidity. And so we have to map out, if you like, pathways over time that may indicate points at which strategies have to change. So instead of protecting a coastal area, you might actually need to retreat or abandon that particular area and move somewhere else. And these are big questions for communities and societies. And that's why the small island states, for example, are so vociferous about taking climate action. The other thing that I probably ought to mention, although is that in taking adaptation decisions, this has got to be done in a context of significant uncertainty. So even though we can simulate global thermodynamic properties of the climate quite well, we're not so good when it comes to the detailed local, regional patterns of weather 10 or 20, 30 years ahead. And this slide shows projected rainfall in a very high emission scenario. That doesn't matter. But what the key point here is that where you've got the filled dots, that's where the models agree, and you've got a pretty robust understanding of the direction of change for. Where you've got open dots, that understanding is less good. It's not that the effect isn't there. There may be quite big effects, but the models are disagreeing, and that's got quite big implications then for policy making, because you need to have decision-making processes that are robust to that uncertainty. Historically, insufficient attention and financial resource has been devoted to making countries more resilient as opposed to reducing emissions. This is now changing as the damaging effects of climate change become ever more apparent, even in developed countries. At COP26, donor countries agreed to double adaptation finance by 2025 relative to 2019, and also initiated the Glasgow Dialogue to discuss the funding of activities to avert, minimise and address losses and damages associated with the adverse impacts of climate change. A further scaling up of action is needed now, particularly for the people that are highly vulnerable to climate risks. Right, let me move on if you'll allow me a bit more time. I want to just talk about the challenges. Why is effective climate action so difficult? I think I can stop sharing for a minute and look at you. Just have a quick change from the PowerPoints. First, the atmosphere is a global common pool resource. Industrialized economies and countries that have deforested have basically used the atmospheric commons as a waste dump for emissions, without perhaps initially realizing the far-reaching consequences this would have. That's no longer the case, of course. And countries differ in their degree of responsibility for these emissions, but we've nearly exhausted the cumulative carbon budget corresponding to a 1.5 target. This all makes development far more difficult for emerging and developing countries. Second, countries differ on many dimensions, as we know: economic, human capital, natural resources, demographics, location, etc., etc. So they're going to have different capacities to reduce and manage climate risks. The poorest and most vulnerable will generally be those countries that have done little or nothing to cause the problem, sharing with the young and with future generations an inability to determine the levels of climate risk that they will face. Climate change therefore raises fundamental issues of responsibility, equity, and justice, and we all know that this is difficult to negotiate and navigate through. The third big challenge is that a stable climate is a global public good, and public goods are non-rival, non-exclusive, and therefore tend to be underprovided. And to the extent that large emitting countries themselves face climate risks and have mitigation options, yes, they're going to reduce emissions, but in a non-cooperative setting, one-off decision, the level of mitigation action is going to be calibrated on national benefits, not on global benefits. And so you're going to have less mitigation than would be optimal. And mechanisms like the Paris Agreement are designed to really overcome that problem by creating repeated interactions and a process of pledging the national determined contributions that I mentioned earlier, transparency and review. The aim is to ratchet up the stringency of action on mitigation over time. We'll see how good that is. A litmus test, if you like, is going to be the extent to which we get revised nationally determined contributions in advance of COP27 in Egypt in November. And fourth, I personally find Jason Moore's argument that our development model fundamentally depends on cheap energy, cheap food, cheap labor, and cheap nature quite compelling. But even if you don't agree, there's no denying that our societies are deeply dependent on fossil fuels and the rents they generate. As the crisis in Ukraine is demonstrating, overcoming what our former Secretary General at the OECD, Angel Gurria, called carbon entanglement in a speech in 2013, is a very tough challenge, and one that we've delayed for far too long. Nearly a decade after that speech, governments around the world are again using the current energy price spike, and the fiscal problems in some countries as a reason to expand exploration and exploitation of oil and gas resources, when we know we can't burn them and keep the climate stable. I just, if I can, spend a few minutes to say something more. Is that okay, Nordine?
Sure, Simon, go ahead.
Yep. Just wanted to make a few reflections, if you like, on the way ahead. What I see as priorities for action going forward. Some of this builds on work we did at the OECD, and I'll refer to some of that. One thing that the OECD was famous for was green growth, but we need to move beyond green growth if we're going to scale up and accelerate mitigation action. Green growth approaches rely on economic fundamentals, if you like, and the assumption that everything works in the way that market economics predicts, which is not true. Carbon pricing and technological innovation are meant to drive a decoupling of emissions from GDP growth. But at a global level, if we look at some of those charts I showed earlier, we only get a relative decoupling at best. The ratio of emissions to GDP, if you like, is declining, but we're not getting absolute falls in emissions, and that's what's needed. And part of the problem is this issue that we have of economies having built-in feedback mechanisms that make it difficult to increase carbon prices to the level needed to drive really transformational change. I'll say more about that if needed, but we'll move on. I should just say, don't get me wrong, we need to price greenhouse gas emissions. Pricing is really important for setting incentives and expectations across the economy, but they're not going to be a magic bullet, and I think for a long time people assumed they would be. And so my suggestion instead is that we need to better integrate mitigation with wider well-being objectives, what people care about. And we mean by this exploiting the synergies between, say, mitigation action, emissions reduction, and wider well-being outcomes such as jobs, income, health, environmental justice. And in this way, ambitious early mitigation action can be made politically, economically, and socially more attractive. So think of, the air pollution benefits that came from remote working. Suddenly our cities were clean in terms of the air quality, and a lot of cities in Europe, in particular, created spaces in which sustainable and active modes of transport, could replace public transport where people were worried about, catching COVID. And these things can happen quite quickly, where people see benefits that are not just the longer term climate benefits, but also benefits in their daily lives. And that's a strategy we need to really bring to the fore in our efforts to tackle climate. And to make that happen, and also to unlock the huge potential of these demand side mitigation measures that I mentioned earlier, we need to take a systems perspective. And if I may, I'm just going to share one last slide. Yeah. This is work that was done by colleagues Aimé Aguiar Jaber and Mariana Mirabile in my division. They've basically developed a process which they call the well-being lens, or the well-being process, to help policymakers think in systems terms and design more effective climate policies. And there's 3 steps to this. One is you envision the outcome that you really want. You understand the dynamics, and then you identify the policies that are needed to redesign the system. And they applied this to surface transport, where we have high traffic volumes and negative impacts, such as, not just greenhouse gas emissions, but also these aerosols, the air pollution, poor road safety, and of course, encouragement of unhealthy sedentary lifestyles. And so they argue that transport needs to deliver sustainable accessibility, the ease with which people can access opportunities, rather than mobility, which is just, the amount traveled. And they identified 3 critical dynamics behind the car dependence of current systems, induced demand, urban sprawl, and the erosion of shared and active modes of transport. And they saw the policies with the most potential to bring about the changes needed were things like street design and the improved management of public space, like we're seeing in Barcelona, spatial planning focused on creating proximity so that you're near all the things you need to get. The idea of the 15-minute city is a very powerful one here. And policies to develop multimodal and sustainable transport networks.
Simon, we can't see the slide, the last slide that you've talked about.
You can't see that. Okay, let me just out of that, and I'll share the slide again. I'm really sorry about that.
It's okay.
I thought it would. Okay. So I hope you can see that now.
Yes, we can. Thank you.
And is it the right slide? Is it the one with the 3?
I think the previous one. Now we're seeing the first one, the first one that you showed, that has the title of the slide. But I think the previous one was the right one.
Yeah.
Maybe if you just go back.
Quickly go through. That's fine. We're nearly there. There we go. So that's the 3 stages: the envision, the understand, the redesign. Okay, I just got a couple more points and I'll finish. I think the other reflection I'd have is that biodiversity loss and climate change have got to be addressed much more closely together. Natural capital underpins all our economic activities and human well-being, but there's a growing gap between our demands on nature and what nature can supply. And if we're not careful, we're going to set up a vicious cycle, a vicious feedback loop between biodiversity loss, which reduces ecosystems' capacity to store carbon, and climate change, which is in itself driving biodiversity loss and exacerbating the problem. So the mitigation pathways that countries choose are going to determine the extent to which there are trade-offs and synergies between climate and biodiversity action. And we arguably need pathways that have lower energy and lower materials demands while ensuring a high level of services and meeting needs. And that's going to have benefits for both of these goals. And as the IPCC Working Group 3 report shows, can meet what we need. We just have to be smarter about the way we build our systems. And then finally, we're now at a political, economic, social, ecological, and ethical crossroads, if you like. Urgent collective action is needed if we're not going to miss what the IPCC has identified as a brief and rapidly closing window of opportunity to secure a livable and sustainable future for all. And if we fail, it might be that what seem like fairy tale dystopian futures could become a reality within decades. And while many climate initiatives like the Powering Past Coal Alliance can and should be pursued outside the UN process, which is too slow and too cumbersome to really deliver that sort of initiative, the UNFCCC process itself remains absolutely indispensable for making the collective choices that are going to affect the future of the whole planet. Now, I could say more, but I'm going to stop because we're running out of time. And I think I'll just conclude by saying that climate and biodiversity are always going to have to compete for political oxygen with other pressing crises, whether the crises are conflicts like we have now in Ukraine, or whether they're financial crises like 2009, pandemics as in the last 2 years, or natural disasters. But in the long run, ambitious climate and biodiversity action is absolutely essential to continued well-being and prosperity of humankind. And so collectively, we need to stay focused and stay on course. Even if we're forced to veer and haul from time to time by the headwinds of circumstances, we've got to persevere. Even if we don't meet 1.5, 1.7, 2 degrees is better than 4 or 3. The risks will get higher the higher we let the temperature rise. So I just urge you to keep the pressure on governments and to keep moving forward in terms of understanding the actions that we need to make these changes in our societies in time to guarantee that well-being. Okay, I think I should stop there and take any questions and discussion.
Thanks. You, Simon, for that inspiring.
Thank you, Simon.
And really something that really needs to a talk that makes all of us need to think about this very, very seriously. Thank you so much. So with that, I think we have the questions coming from the audience. So maybe Liz, you can read a few questions.
Sure. I have 2 right off the bat. This one is it looks like it's multi, but I'll do my best. What steps can we take to reduce the influence of anti-climate propaganda disguised as educational information, such as, I might pronounce this incorrectly and I apologize, PragerU? I feel like this is from the person asking the question, I quote, "I feel like I run into constant issues of having to break down misinformation before I can even begin to educate people about the climate crisis."
Yeah, I mean, I think that's a challenge that was present, but in a less virulent form 10 years ago. I mean, things like platforms like Facebook have really if you like, amplified the problem, and often people are talking in echo chambers to each other about things that they think are true, which may be just a partial truth, or even maybe not even true at all, and certainly don't invalidate the science and the policy prescriptions that come from these IPCC summary documents that the governments of the world have all agreed. They've agreed those key messages based on the science. And so I'd say that the key thing we do is all the time we go back to this fact that the evidence is absolutely solid. Yes, everybody has difficulty in saying what the climate will be precisely in location X at time T in 10 or 20 years' time. But we know that climate change is happening. This is just fundamental physics and chemistry. We understand that. The question is, what are we going to do about it? And that's where the political debate should be on what do we do. Now, I sympathize, and I think it's frustrating to debate these things. I don't think you can have a debate often with people that are so entrenched. You try to bring the evidence, and you let others, a wider audience, make up their mind about the value of that evidence. And if you do it in a calm, considered way with good evidence, people start actually pushing, retreating a little bit from their positions. Some of these deniers, I won't call them skeptics, that's giving them too much credit, but some of these deniers, really are just picking on tiny aspects of physics that they don't even understand. And a lot of the books written by them, is full of misunderstandings as well. So I think just keep to the evidence, keep it neutral, keep it calm, but be very clear about what's at stake here. And I think also you can inquire about a lot of people, yes, they're picking up stuff and they're replaying it on social media, but there are organizations that are well funded and they don't keep they don't necessarily set out who's funding them, but quite often it's interests in the industry that would oppose the removal of fossil fuels from the energy landscape. And I think asking people about, well, what is your interest? Are you a neutral person here? The critics, the deniers often criticize scientists. You've got an interest in this because your career is science. No, I'm sorry. Science is about, objective analysis, testing of hypotheses, and basically, getting to the best idea of truth that we can have. And the idea that scientists are in some way, biased and involved in some conspiracy to get funding is absolute nonsense. So I think we just have to keep pushing back.
Okay, thank you. Another question has come in. What type of things can one do on an individual level to mitigate climate change?
Well, depending on where you live, if you're in a city, you can use public transport, you can use bikes, you can walk, active modes of transport. In terms of diets, dietary choices can have a big impact on your own personal carbon footprint. It may not change the industry initially, but as we see, demand for meat substitutes, the demand for non-dairy milk and butters, it's all growing. And if we can at least reduce the amount of meat, not stop it even, but just reducing the amount of meat in the diets, these sorts of issues, these sorts of changes, they're going to make a big impact if replicated globally. They're not necessarily going to be, but if replicated globally, they could make a big difference. And again, big vested interests in the food industry. So that's another battle. You're taking on fossil energy, you're taking on industrial agriculture and food industries as well in this. So this is why it's not easy. It isn't easy at all. But you can make changes, and we see the trend certainly in the UK. I don't know about the US, but certainly in the UK, you're seeing vegan options in restaurants. You're seeing dairy-free options on the shelves of the supermarkets. It's happening. And gradually, other firms will latch onto this and they'll see profit in that. And then you've built a constituency that's actually in favor of that change. It's not just resisting it, it's actually in favor of it. And I think, if I'm not mistaken, I think organic farming in the US is pretty vibrant. It's growing. So those sorts of changes, are possible, but they will be supported by individual choices and action. Yeah.
All right, thank you. This question comes in from Juliet Rooney-Varga, who's one of our faculty members here in the college, and she's also the co-director of the Rist Institute and the director of its climate change initiative. And she says, I was grateful to hear you mention our efforts. Thank you. And I'm always interested in learning how to better. Our faculty are often eager to engage with decision makers and communicate our work to broader audiences. But as you mentioned, academic initiatives often lie elsewhere. What have you found works to give faculty members space, time, resources to translate our science into much needed action?
Okay, so that's a really good question. I mean, this is something we struggled with a lot, and we basically had to put money into the equation. So that was either we paid a bit of a postdoc's time to write a briefing paper that addressed a key issue. Maybe we thought that we could have a PhD student working in a particular area, and therefore some of that time from that PhD student would be spent in engaging with policymakers and writing material, researching issues. Or maybe we could just actually rely in some cases on the sheer commitment of academics, but that was maybe a dozen out of a few thousand at Imperial that would have that level of commitment. And so you have to work with what you've got. And I think finding out what academics need to help them to do their job helps you to then see how they can help you to do yours. And it's that dialogue that is really important. And I say money, but it isn't always money. It can be just the fact that you organize a meeting and you manage to get some government officials to turn up. And this is the first chance that these other academics have had a chance to sit in a room with them and talk to them about their research. And that's very valuable and that's attractive. And it doesn't cost money, it costs time, but not money. So there's things like that that you can do as well. But I'm happy to talk more offline because I think that would be an interesting discussion.
Awesome, thank you. Next question. What is the viability of international geoengineering projects, such as cloud seeding and space mirrors, in quickly reversing or preventing the effects of climate change?
Well, there's no doubt they would have an effect. The trouble is we don't know precisely what effect they might have, and they could be quite dangerous. Mirrors in space are going to change the whole energy flow into the Earth system. They're going to change weather patterns. You could disrupt maybe the Indian monsoon. You've got 1 billion people there, a lot of them dependent on agriculture for their livelihoods. Are those the sorts of risks you're willing to take with some of these solar radiation management type schemes? I don't think so. I'd much rather actually use tried and tested technologies to stop the problem at source. Another thing with some of these solar management schemes is they don't actually address things like the acidification of the ocean. The CO2 that we're pumping out, if that continued just because you're basically blotting out some of the sun's energy, and you're still pumping out the CO2, it's still acidifying the ocean. You're still losing your marine life, your coral reefs, your shellfish, and so on. So it's not really a full solution. I mean, you can imagine those sorts of things being deployed, by an individual powerful country, but you're never going to be sure that it's not going to have major impacts on other countries around the world, and it's not going to solve the problem in its entirety. It's not something I'd countenance easily.
All right,
Carbon dioxide, just at a rider. I mean, there's two forms of geoengineering broadly. One is this solar radiation management, the mirrors in space. The other is the pulling the CO2 out of the atmosphere. I think that second is much more, it's needed. It's going to be needed to keep climate risks at a tolerable level. And that's where things like, big efforts to increase forest cover, afforestation, or to have bioenergy enhanced carbon capture and sequestration, or even direct air capture of CO2, which is very expensive because CO2 is very dilute in the atmosphere. If you can capture it coming out of a power station or a cement factory, it's much cheaper than if you're trying to just pull it out of the air. These are parts per billion and parts per million of greenhouse gases, billion for the methane, millions for the CO2. So we need those carbon dioxide removal technologies. I think we've delayed action so long that we can't get to 1.5 or below 2 without those things now.
Awesome, thank you. And then I have one more general question that's come in. First part, would it be a good idea to continue postdoc right after completing a PhD? And then the second part is, what experiences could you share when decided to work abroad?
Well, I think it depends on what you want to do with your life, what you choose to do. I sort of stumbled into a postdoc, and I was very fortunate that it was a really fun group, a really exciting group. But I didn't want to be a scientist for the rest of my career. So, I only spent a year as a postdoc, and you could say, well, that was a bit of a waste of time. I'm not sure it was, but if you're clear on what you want to do and you've done your PhD and you know that you don't want to be a researcher, maybe, you should be thinking about moving into something else early on. That would be my personal view, but it's not professional career advice. That's just my own personal reaction, as it were. And in terms of working abroad, I guess it's easier if you're working, for an institution that's going to look after you a bit, because it's difficult when you make the transition. You're thrown into a completely different culture, different workplace, different even physical environment, and it can be difficult. Even places like the Republic of Ireland, you'd think that's so close and so near and so similar to the United Kingdom that working there would be just the same as working in the UK. I spent 3 years there, and I can tell you it isn't. It's a completely different country, a completely different culture, and it takes a lot to adjust to that.
All right. Does anyone? Oh, here's another question just came in. Fantastic. What is the viability of nuclear energy in rapidly decreasing our dependence on fossil fuels?
Okay, I think there's several dimensions to this, but let me keep to a couple. I mean, one is that a lot of countries have existing nuclear plants, and they were about to, or were planning to, phase them out. Germany basically stopped a lot of its nuclear generation after Fukushima in 2011, and now scrabbling for energy. France has a large part of its electricity from nuclear power, and that may continue. Other places, like in the UK, it's a smaller share, and it's going to be very expensive to replicate, or to replace the aging reactors. The costs of nuclear and the delays also in many cases are what's critical. We lost a lot of technical expertise between the sort of 70s and now. There was a whole nuclear industry and technical expertise that is now thin on the ground in a lot of the Western countries. Where it's strongest, is places like China, I guess, and universities like Imperial, Manchester, and a few others, actually did a big effort to boost their training for potential workers in the nuclear industry. So, technically we know it works. It's certainly got a big role potentially to play as baseload when you've got intermittent renewable. There's a lot of your generation on the grid. You've got to think about the expense, the capabilities, and the timescales over which you can develop, the industry. If you've let it stagnate, how do you get it up? And nobody's solved the long-term sequestration problem, the long-term burial problem yet. How do you get rid of this stuff safely? On top of that, you've got proliferation concerns and a number of other worries, accidents. We've just seen the Russians bombing nuclear power stations in the Ukraine. So, a lot of considerations, and some societies will just completely veto it. Others will be reasonably comfortable with the risks and will be prepared to implement nuclear, as one element of their strategy. I don't think there's a blanket answer.
Well, thank you, Simon. I think I actually had 3 questions, but I'll just ask one because of the time. So you are probably aware of the work that Corinne Lepage, who was actually the Minister of Environment, and Daniel Juppé is doing. She one of the efforts she's making is to have the UN approve a new human rights declaration that would include also the health of the planet. And I wanted to know what you think about that, if actually something like that goes to the UN, where the entire world actually votes on it and decides to do something about it, about the health of the planet, just like they're not doing much about human rights, but you know what I mean. But at least, do you think that will help, or do you think that's actually something that is just a shot that's not going to go anywhere?
Yeah, my instinct is it's the latter. I mean, we've already got a lot of linkages between, human rights and things like climate and biodiversity crises that could already be exploited, and action could be taken in the UN in terms of many rights. because they're being undermined or threatened by climate change. I think legal remedies, are powerful. There's no question. I mean, we've seen the German government have to increase the stringency of its climate commitments due to legal action. We've seen, I think, Shell, being taken to court in the Netherlands, if my memory serves me correctly. I couldn't swear to that, but these have actually been effective in forcing action. So legal remedies and legal challenge is a very powerful way of taking action. It's in some ways more direct and more impactful than even thinking about disclosure of climate risks. Transition risks are only transition risks to the extent that governments put in place policies that force companies to have a different business and a different business model and think about the risks and opportunities. And so, anything that increases the scope to use the legal system to support climate action, I think is useful. But I'm skeptical about that particular proposal.
Yep. Well, thank you so much, Simon. We learned a lot. This is inspiring, it's challenging, and I think you brought the point very, very well. This is something that's global, touches all of us, our future. And I hope everybody here has benefited from this talk as well, as I'm sure they have. So on behalf of the Kennedy College of Sciences, on behalf of everybody else present here, on behalf of the Chaisson family, thank you so much, Simon. And we hope to see you here. At least I hope to see you here in Westford sometime soon. So yeah.
Thank you, Simon.
Thank you very much.